Okay, hey guys, this is our third video, and today we are going to be doing arithmetic progression and geometric progression. And in this video, we're going to cover the theory, and in the second video, I'll cover questions and what the questions come like. Okay, so first, an AP, or as we call it, an arithmetic progression, is a sequence in which consecutive terms differ by a constant. Okay. What this means is that if we take the un plus 1 term minus the un term, it's equal to a constant. Basically, remember we said that u of 1 is equal to the first term and u of 2 is equal to the second term. And if we were to subtract these, this would be equal to a constant. Okay? And note here now that this is for consecutive terms is equal to a constant. So this would also be equal to, let's see, u51 minus u50. Okay, and they're all supposed to give us a constant value. So that's why we could generalize it and say that un plus 1 minus u of n is equal to a constant. So let's say we have an arithmetic progression of 1, 2, 3, 4. Okay, now to determine if it is an AP, all we simply do is take a term and subtract the term before it. Example, right? Well, to show this is 2 minus 1 should be equal to 3 minus 2, which should be equal to 4 minus 3, which is equal to 1. Okay? So they all differ by a constant term. Again, let's say we have 2, 5, 8, 11. If this is an AP, it should all differ by a constant term. So again, we'll have 5 minus 2, sorry, is equal to 8 minus 5, which is equal to 11 minus 8, which is equal to 3. Okay, so realize that each consecutive term differs by a constant, and in this example 2, it differs by the constant 3. So let's say we have another example now, example 3, in which let's say it is 3, 6, 10. Okay, to determine if this is an AP, all we simply do is 6 minus 3 equals to 10 minus 6. Now this 6 minus 3 is 3, 10 minus 6 is 4, and these are not equal to each other. Okay, so what that means is that this here is not an AP. This is not, because it needs to always differ by this constant term. So for AP now, we have some common notation. The first term in an AP, remember we call the first term u of 1. So in an AP, we assign it the letter A. Okay, so if ever we're referring to the first term, we refer to it as A. The number of terms, we use the letter N. Okay, so if I want to find, let me say, the fifth term, it would be u of 5. Okay, and the common difference is this constant. The constant that we mentioned before is the common difference. So in this case, the common difference was 1. Here, the common difference was 3. Okay, and we realized that we say it's called a common difference because each consecutive term minus the term before it, it should always give you the same value. And we assign this the letter D. Okay, so if you want to find the nth term in a series in this arithmetic progression, we have a simple formula which we use. We say T of n to find the nth term is equal to A plus n minus 1 times D. Again, so an example, let's say we want to find the fifth term. We want to find T of 5 given that the first term is 2 and the common difference is also 2. So it would be 5 minus 1. This would be equal to 2 plus 4 times 2, which is equal to 10. Okay, so again, if you want to find the nth term, we just use this formula here. T of n is equal to a plus n minus 1 times d. Let's say now we want to find the sum of the first 10 terms. So if we go back to example 1, we have the terms 1, 2, 3, 4. Let's say I want to find 1 plus 2 plus 3 plus 4. Or for example 2, I want to find 2 plus 5 plus 8 plus 11. Okay, we have a formula for that too. We use the symbol S of n for that, and it refers to the sum of the first n terms. Okay, and this is equal to n over 2 multiplied by 2a plus n minus 1 times d. So let's say following from the example above, we saw that the first term was 2 and the common difference was 2. Okay, so let's say I'm going to find, we want to find the sum of the first 100 terms. So we'll say S of 100 is equal to 100 over 2 multiplied by 2 multiplied by 2 plus 100 minus 1 times the common difference, which is 2. Okay, so what this will give you is, and this gives you the value of 10,100. Okay, so this is to find the sum of the first n terms, so we have a formula for it. Okay, S of n is equal to n over 2 multiplied by 2a plus n minus 1 times d. Okay, a geometric progression is different. So for an arithmetic progression and AP, we had a common difference. The difference between a geometric progression and an arithmetic progression is that a geometric progression has a common ratio. Okay, so it has a common ratio between consecutive terms. So again, we use the general formula un plus 1 over u of n is equal to a constant. This is the same as saying the second term over the first term is equal to, let's say, the fourth term over the third term, and this is equal to a constant. This constant, we call this the common ratio, right? So that's the difference between an AP and a GP. One has a common difference in which we subtract consecutive terms. This one has a common ratio in which we divide consecutive terms. So an example is, let's say we have 3, 9, 27. Okay, so all we do is we say u the second term over the first term, which is 9 over 3. Now a common mistake some people make is putting this term over this term, okay, and rather they get 3 over 9. This is wrong. Okay, we can't do that. So we get 9 over 3 is equal to 27 over 9, which is equal to 3, and therefore 3 is what we call the common ratio, which is a constant. Okay, let's say this was not equal to each other, then we would not have had a GP. It would have been a different kind of sequence. Okay, so again, the terms to be used is roughly the same. The A represents the first term, R represents the common ratio. Remember, in an AP we had a D which represents the common difference, and N refers to the number of terms. So the nth term in this sequence, the nth term of a GP, is given by T of n is equal to A multiplied by r to the power of n minus 1. Note r alone is to the power of n minus 1, not a. Okay, so let's say I gave you a sequence in which the first term was 5 and the common ratio was 1/3. Okay, let's say we had a sequence and I told you to find the fourth term, so therefore all we have to do is T of 4 is equal to E, which is 5, multiplied by R, which is a third, to the power of n minus 1, so 5 minus 1. Okay, so 3 by 3 is 9, 9 by 3 is 27, 27 by 3 is, sorry, 3 by 3 is 9, 9 by 3 is 27, 27 times 3 is 81. Okay, so what we'll get is 5 over 81 as the fourth term. So let's say here now I want to find the sum of the first n terms. Okay, this is given by a formula. S of n is equal to E multiplied by 1 minus r to the power of n. Know where this n is. It's 1 minus r to the 1 minus r to the power of n. Okay, the 1 minus r is not to the power of n, just the r alone over 1 minus r. Okay, so let's say using the same a is equal to 5 and r is equal to 1/3, I want to find the sum of the first 10 terms. Okay, all it will be is a, which is 5, multiplied by 1 minus r to the power of n, which is 10, all over 1 minus 1/3. Okay, and it's as simple as that. And this will give you the sum of the first n terms. Okay, and now we have something called the sum to infinity. Okay, what this basically says, right, is that if we continuously add all the terms in a geometric progression, they approach a point. They do not reach the point, but they approach a point, and this point is called the sum to infinity. So let's say we was to add up an infinite number of terms, they would all approach this value, and this value we use the sum to infinity to find it. Okay, and the sum to infinity is equal to a over 1 minus r. Now this sum to infinity has a condition, and the only way you could find the sum to infinity is if r is between 1 and minus 1. If this condition is not met, you cannot find the sum to infinity, and you cannot use this equation. Okay, so you need to make sure that r is between minus 1 and 1. Okay, so in this case we could use the values we were using, since a was a 5 and r was 1/3, and r 1/3 is between minus 1 and 1. So we could use this equation to, if you want to find the sum to infinity, okay, the sum to infinity would be a, which was 5 over 1 minus 1/3, which is equal to 5 over 2/3, which is equal to 15 over 2. Okay, so for this sequence, the first term is 5, the second term is 5 multiplied by 1/3. The next term, so the first term here, this is a times r. Then we have 5 multiplied by 1/3 multiplied by 1/3, but then this would be 5 multiplied by 1/3 squared, and this would give you a r squared. Okay, then we'll have 5 multiplied by 1/3 cube, which will give you a r cube. And what this says is that if we add these terms, if we add an infinite number of terms, they would approach this value. They would approach this value, which is 7.5. It would never cross this value. Okay, but again, remember, to find the sum to infinity, r must be between minus 1 and 1. And this is the end of our lecture on arithmetic progressions and geometric progressions. Please, the important things to know for this is to memorize the equations, because you need to know them, and look forward to another video where we discuss questions related to EPs and GPs. Thank you.